Today we're going to talk about L'Hopital's rule, and this is a really useful tool for finding limits. So what this rule says is, if direct substitution yields an indeterminate form, which is either 0 over 0 or infinity over infinity, then the limit as x approaches to c of f over g is equal to the limit as x approaches to c of f prime over g prime. The reason this works is because it tells us how fast these functions approach 0 or infinity. So imagine the limit as x goes to infinity of f is infinity, and the limit as x goes to infinity of g is also infinity. Let's imagine that g approaches infinity faster than f. What this means for the quotient f over g as x goes to infinity is that g will always overpower f in terms of size. But not only that, g also grows faster than f, meaning the gap between f and g grows bigger as x grows bigger. What this means is that as x grows larger and larger, this quotient is driven to 0 because g overpowers f. So from this example here, you can see why it's so valuable to compare the rates of change of these two functions to determine the overall limit. So while f and g both do approach infinity, the relative speeds at which they do so significantly impacts their limit of their quotient. And another thing you know is that L'Hopital's rule can be applied more than once so long as we keep getting indeterminate forms, as you'll see in this problem. We're finding the limit as x goes to infinity of x squared plus 1 over e to the x. And direct substituting infinity into here yields infinity over infinity, which is an indeterminate form. So we can use L'Hopital's rule to solve this problem. We can say, by L'Hopital's rule, this is equal to the limit as x goes to infinity of the derivative of x squared plus 1, which is just 2x, over the derivative of e to the x, which is e to the x. You'll see that if we try to direct substitute again, we still get an indeterminate form. So we have to apply L'Hopital's rule one more time. By L'Hopital's rule, this is equal to the limit as x goes to infinity of the derivative of 2x, which is 2, over the derivative of e to the x, which is e to the x. And now when we look at the behavior of this function, we see that as x goes to infinity, e to the x also goes to infinity, meaning 2 over e to the x grows to 0, and that is our answer. To finish off the video, we're going to do this last example. I have the limit as x goes to 0 of 4e to the x minus sine x minus 4 all over x squared plus 4x. If we direct substitute 0, we see that we get 0 over 0, which is an indeterminate form, so we are allowed to use L'Hopital's rule. So by L'Hopital's rule, this limit is equal to the derivative of the top function over the derivative of the bottom function. And when we direct substitute 0 here, we get 4e to the 0 minus cosine 0 over 2 times 0 plus 4, which equals 4 minus 1 over 0 plus 4, which is 3 over 4, and this is our final answer. And that's how you use L'Hopital's rule.